All right, so we have a problem here from 2016, and looking at the graph, I see something that resembles a rotation problem. So immediately it makes me want to think this is a type 4 problem where I'm going to be calculating area and volume. In truth, after further reading the question, I calculate volume on one part of it, but the other parts aren't really area volume questions. So this is also maybe a type 7 question because more of the points from it come out of the ideas that fall under type 7. We're talking about related rates and other things that don't fall into our standard 6 types. So in part A, they're asking us to find the average value of the radius. And for us, they give us a radius equation. R is 1/20th of 3 plus height squared. And they want us to find the average value of this. So we're looking for average function value. And if we dig in our memory banks of how to calculate average function value, that was a case of 1 over b minus a integral a to b of the function. That's your general go-to form for average function value. So we want to do that for this equation here. Our radius is 1/20th, 3 plus h squared, dh, (1 over b minus a). So we have to figure out what is b and what is a. Those are going to be the upper and lower bounds of our height, and they tell us the height goes from 0 to 10. So 0 to 10 is the boundary. This can be simplified a little bit before we get into the calculus. 1/10 times 1/20th is 1/200th. Of 3 plus h squared dh. So there's our simplified integral expression. And to find the value of this integral expression, it is not calculator active, so we have to do this by hand. And the antiderivative of 3 is 3h, and the antiderivative of h squared is h cubed over 3. And we are going to evaluate this from 0 to 10. So plugging in our upper boundary, we get 30 plus 100 thirds. Plugging in our lower boundary, we get 0 plus 0 thirds. 100, oh sorry, that should be 1,000 thirds. And this is a numeric answer. It gets us everything that we need. However, some people enjoy simplifying things a little bit. So if we were to simplify this, this would be 90 over 3. So what we have is 1 over 200 times 1090 over 3. Which is 1090 over 600. Got to close my parentheses. Thanks, Zeppelin. So there's 3 points for this. 1 point comes from having the integral. And whether you've kind of simplified the integral or not, that 1 point comes out of the integral. As long as it's mathematically correct, you're going to get the 1 point from the integral. 1 point for having the antiderivative correct. And again, whether you pulled that 1/20th to the front or not, it's not going to affect that. And then 1 point for the answer. Now the answer technically can be reduced and technically has units, but as long as the numeric part of your answer is correct, you'll get that 3rd point on part A. So those are your 3 points. All right, moving on to part B, which is really the trademark of a type 4 problem, finding a volume. And what we have going on here, if you were to picture this on an XY axis, you have your vertical axis and you've got your horizontal axis. So R is synonymous with X and H is synonymous with Y. Okay, if you're wanting to compare it to variables X and Y. And when we talk about a representative triangle or rectangle being the slice that we take for our perpendicular method, that is what the rectangle would look like. So in volume, our go-to super generalized formula is pi integral a to b of the big radius squared minus the little radius squared. In this case, it would be dy. Now, because we don't have a core being removed from the center, it's not a washer, it's just a disk, our formula is even better said as just big R squared dy. And we need to figure out what is that big R. Well, for us, big R is the radius, and they give us that equation. So in the context of this problem, R is 1/20th 3 plus h squared. Okay. Minus 0 because the rotation line is at 0. So that's our big R. We're going to square that. And our y coordinate is actually, in the context of a problem, an h coordinate. Our upper and lower boundary for the h is we start at a h of 0 and finish at an h of 10. So 0 to 10. That is the integral expression that we need to evaluate. Okay. So now that we've set this up, we're going to start doing the cleaning it up before we find the antiderivative. So 1/20th squared is 1/400th, and it's a constant, so we can pull that 1/400th to the front. If I squared the 3 plus h squared, I'm going to get 9 plus 6h squared plus h to the 4th. So again, 1/20th squared gives me that 400, and then the 3 plus h squared gives me this. We're now at a state where we can find the antiderivative using our antiderivative rules. 9h plus 6h cubed over 3, which reduces, plus h to the 5th over 5. This is being evaluated from 0 to 10. Let's actually evaluated from 0 to 10. 90 plus 2,000. Right, h cubed is 1,000. 6,000 divided by 3 is 2,000. And then h to the 5th, 10 to the 5th would be 1, 2, 3, 4, 5 zeros. And there's a numeric value for the volume, which can be cleaned up, but this is numeric and you're limited on your time on the AP test. I would stop at this point here. Oh, there is a subtract 0, but I didn't write it down. So h of 10 minus h of 0, or where h equals 10 and h equals 0. Okay. The points on this come from the integrand, which is the interior piece. And I believe on the last part I said a point for the integral, and I only underlined the integrand. The integral includes the whole shebang with the upper and lower boundaries and the variable of integration. But so in part A, you got a point for having the integral correct, which would have been all of this. In part B, you're getting the point for having the integrand correct. Your second point comes from the correct antiderivative. And again, with my antiderivative, I pulled that 1/400th to the front. So it is wrapped into that right there. And then your final point comes from the answer. And I don't recommend simplifying it, but I've included the simplification right there. It is volume, so if we are going to have units on it, the volume is defined as inches cubed, because R and H are taken in inches.
Oh. Does it feel good?
All right, moving on to part C. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 of an inch per second. At this instant, what is the rate of change of height of the liquid with respect to time? They are looking for dH dt. What is the rate of change of the height with respect to time? So that's your find request. When are we looking for that? We're looking for it at the instant when h equals 3. So we're going to do a related rates problem where we are looking for this rate when we are given another rate. And that rate is the radius is decreasing at negative 1/5, or sorry, is decreasing at 1/5 of an inch per second. So because it's decreasing, I make that value a negative thing, negative value. So we have the relationship between R and H. We can distribute that 1/20th if it makes it easier to understand, and we don't have to do the product rule then. We're looking for a rate of change with respect to time. So if we take the derivative of this with respect to time, we're going to get dr dt equals 2/20 h dH dt. Remember, there's the chain rule that needs to happen, and that's where that extra piece at the end came from. Implicit differentiation or chain rule there. Find when given. We have this number, 2/20 we have h, and we're looking for dH dt. So we can plug in the things that we know. H is 3, and dH dt is unknown. Negative 1/5 equals 6/20 dH dt, or negative 20/30 equals dH dt. Which makes sense that it's negative. If you want to picture this, the radius is, or the water is draining out of the funnel, so the height would be dropping over time. So negative 2/3 of an inch per unit time. The unit time that we were talking about is in seconds. Okay. This is worth 3 points. 2 points come from including the chain rule. So that's the idea of remembering to include that dH dt at the end when you take the derivative with respect to time. 2 points out of that. That might be divisible, but I don't know. 2 points. And then the third point comes from having the correct answer. The units are not required on this problem, but it's always good to understand the units. Be sure to comment, like, subscribe, mash that button, smash that like button, send money to my Bitcoin wallet, hit the bell for notifications, follow all of my students on Instagram and their vlogs and all of that jazz. Anything to add, Elise? A quiet no.